This is the sixth video. In this video, we are going to study the stress strain curve. This is the second video on stress strain curve. The topics covered here are stress strain curve for brittle material, stress strain curve for taut steel, and proof stress. Here, this is the stress strain curve for a brittle material. When a brittle material like cast iron is subjected to gradually increasing tensile load up to fracture, then this is the stress strain curve obtained. This is the stress strain curve. On the x-axis is strain, y-axis is stress. This point A is limit of proportionality, B is elastic limit, C is ultimate point, and D is the breaking point. So the point A, limit of proportionality, that means up to point A the graph is a straight line. Here stress is proportional to strain and Hooke's law is followed. So from here, from the origin here up to A is the straight line. Point B is elastic limit. So up to point B the material behaves as an elastic material. Then this is the point C, where the ultimate point, which is called as ultimate point, and at which the stress is maximum, and this stress is called as ultimate stress. Ultimate stress is the maximum value of stress that a material can resist. Beyond this point the material breaks at point D. Point D is a breaking point at which the material fails or breaks under tensile load. This stress at point D is known as breaking stress. But sometimes brittle material breaks at ultimate stress only, or it immediately breaks after the ultimate stress. This C to D distance is not much. Here is the figure. In this figure 1, the brittle failure is shown, how the brittle material fractures. And in this figure 2, you can see here this is a cup and this is a cone formation, and that is a failure for ductile material. Here there is another figure. In this figure, this top bar here, it has shown broken, and this is a cup cone fracture. Here you can see the formation of a cup where it is broken, the part has come out, and the cup we cannot see, this part is a cup. And here at the bottom, this is the neck forming which takes place in the ductile material before failure. Now this is a stress strain curve for the taut steel. Now for the taut steel, this is a stress strain curve. Here point A is a proof stress, B is the ultimate stress, and C is a breaking stress. Here what happens is, it is practically difficult to locate the elastic limit, and the yield point is a point on the stress strain curve that indicates the limit of elastic behavior and the beginning of the plastic behavior. So prior to the yield point, a material deform elastically and will return to its original shape when the applied force is removed. Once the yield point is passed, some fraction of deformation will be present and non-reversible, and it is known as plastic deformation. The yield stress is often defined as the stress at 0.2% strain, probably because this value can be determined with an higher accuracy than the stress at which the deformation will become plastic instead of elastic. So it is very difficult practically to locate the elastic limit or the yield point. So what is done is, from this origin a tangent is drawn, and to this tangent from the 0.2% strain, a line parallel to this tangent is drawn here, and suppose this is meeting at point A, then whatever is the corresponding stress at A, that is called as proof stress. So a proof stress is a level of stress at which a material undergoes plastic deformation. More specifically, proof stress is often defined as the point when the material undergoes an amount of plastic deformation equal to 0.2%. Proof stress is also known as offset yield stress. So this is how we get the proof stress in the stress strain curve, and usually that stress is used for the design. Now sometimes we get a stress strain curve like this, where this point 1 is limit of proportionality, this is the proportionality limit, this is the elastic limit, and this is a offset yield strength or a proof stress. The yield strength or a yield stress is a material property and is the stress corresponding to yield point at which the material begins to deform plastically, and the yield strength is often used to determine the maximum allowable load. So we want this point here. What is done, if we get this as a straight line and the slope of this line is the modulus of elasticity E, then we from the point to 0.2% strain, we draw a line parallel to this line. This dotted line is parallel to this line. So slope of this line and this dotted line is same, both are E. And from this dotted line, wherever it touches this graph here, this point is taken as, the stress at this point here will be taken as proof stress, or it is sometimes called as offset yield point. And yielding is a gradual failure mode. So this is how it is taken. So this is how we calculate from the graph the proof stress. Thank you. Be a master.